So again, so now come to the node number 1 and 2. At node number 1, let us try to define the displacement. So let us say that the Q1 would be the displacement at node number 1 and the Q2 would be the displacement at node number 2. So means that I can say the displacement would be the now variable. So in the previous slide, we have seen that the x is a variable. So x can be defined as it is a function of the shape function n1 as well as at node point 1 the coordinate value is equal to x1. So n1 x1 plus I written that into x2. So at node number 2 the value is equal to the x2. So this would be the what is that the variable function that can be valid throughout the element. So where n1 and n2 are called as it is called as a shape function. Now I would like to define the what would be the displacement function. So let us say the displacement function as a displacement function q would be defined as it is equal to the a naught plus a1 times of zeta. So I know that one in the previous slide I've defined that the a naught and as well as a naught is equal to I have defined that x1 plus x2 by 2. Similarly, for if you express that in terms of the q's, and this can be defined as it is equal to the q1 plus q2 by 2. Let us try to see how we are going to get this one. So let us try to express the displacement function at node number 1. So at node number 1, the q1 can be written as it is equal to the e naught minus of a1. Okay, so because the zeta would be at the same time, we can say at node number 1, the zeta becomes that it is equal to the minus 1. At node number 2, the zeta becomes that it is equal to plus 1. So if you have expressed the displacement function, therefore at node number 1, it would be the q1 would be equal to the a naught minus of a1 because here you are going to get that a naught plus a1 times of minus 1. So therefore, it can be written as q1 is equal to a naught minus of a1, similar to the last case. Similarly, at node number 2, the q2 can be written as it is equal to the a naught and plus is equal to plus a1. So these two functions can be possible. So from this one, it is possible to define that the a naught would be equal to the q1 plus q2 by 2. If you add that, let us say this is equation number 1 and 2. If you add the equation number 1 plus 2, then you will get the a naught. And if you deduct the 2 minus 1, therefore you are going to get the a1 values. That a1 would be equal to the, it is equal to the q2 minus q1 by 2. Okay, q2 minus q1 by 2. So once you know this one, then we have to substitute this with the interpolation function q, that is called azimuth displacement function. Q would be equal to a naught is equal to the q1 plus q2 by 2 and plus a1 would be q2 minus q1 by 2 times of zeta. So now let us separate the q1 terms and q2 terms. So if you separate the q1 terms plus q2 terms, the q1 terms can be separated as 1 minus zeta by 2 and q2 terms can be separated the 1 plus zeta by 2. So the above equation can be expressed as q1 plus q2 by 2 and multiply that q2 into zeta minus q1 into zeta. Then you have to separate the q1 and q2 terms. Now I can able to say that this is called as a shape function n1 and this is called a shape function n2. So therefore, now using isoparametric representation, now using that above the using from the past two slides, I've expressed that there is a two interpolation function that can be possible to express that. One is called as a displacement function, second one is called as a x variable. So I have expressed that the x is equal to the n1 x1 plus n2 x2 for a simple bar. So simple bar element. So the bar element having a nodal number 1 and nodal number 2. At nodal number 1, I call this as x1 is a variable, x1 is a geometrical coordinate, and at nodal number 2, x2. So I call that at nodal number 1, q1 would be the displacement, and at nodal number q2 would be the displacement. I know that if you have expressed in that zeta coordinate, the zeta at nodal number 1 would be the -1, the zeta at nodal number 2 would be the +1. So using this two notation, I have expressed that the x variable can be defined as n1 x1 plus n2 x2. Similarly, the displacement function can be expressed that it is called n1 q1 and n2 q2. The same thing I have expressed in the by using the last two slides.